So let us start our discussion. So in previous class, I discussed to you about the homogeneous equations in which the right hand side was, you have seen, that was equal to 0, and we did all type of calculations. But it is not necessary that the right part will be 0. So our equation may have this form: d2y by dx2 plus p dy by dx plus qy is equal to r. This is the general form of the equation. Okay, this is the general form of the equation: d2y by dx2 plus p dy by dx plus qy is equal to r. And if r is not equal to 0, then it is non-homogeneous. Okay, and in non-homogeneous, what will happen, that the method of calculation will be how you will calculate the value of y, which is the solution of the differential equation. As a first part, you will put r is equal to 0 and you will solve like you have done. That will be known as complementary function for y. And then as a second part, so this part is the previous part which we have been doing in for homogeneous equation. ये part तो हम करते आ रहे हैं. So this part is for homogeneous equation. And what is the second part? Second part is if I write the function as in the operator form. So it is this, you remember, because the FD is what? It is D square plus PD plus Q, if you remember. Okay, याद है ना ये वाला? So this is FD into Y is equal to R. FD into Y is equal to R. This is the equation. Now what to do? How to solve this equation? So for solution of this equation, when we get this y, which is known as particular integral this time, what we do is we write it like this: 1 upon fd into r. And please remember, this is not something ordinary. This is just an operator. So you have to be very careful while solving this part, because this is some operator, because capital D is an operator. D is t by dx. This is a form of an operator. So now the actual solution will be given by complementary function plus particular integral. That will be the complete solution of y. So this is the method we will be using to calculate the value of complementary function as well as particular integral. ये तो आपको ये सारी चीजें पता ही हैं. Just a quick revision. And if you don't know, then दोनों ही case में you have to pay attention. If you know, then it is a quick revision. If you don't know, you have to just learn this method. Okay, and let me tell you that this method of calculation of this 1 upon fd into r depends on the type of r we have, because right side is capital R. It may be an exponential function, sine function, cosine function, algebraic function, multiplication of two functions, etc, etc. So we will see how to manage it. Okay, so if you have noted it down, I will just jump on this, the particular integral.
1 minute, sir.
Yes, you can take it down.
Excuse me, sir.
Yeah.
What is CF and PI?
What is CF?
Yes.
Complementary function. And PI is particular integral.
Okay, sir. Thank you.
Particular integral. And this is complete solution. So the solution of y of this equation will be CF plus PI. Is that okay? So let me come to this point now. इस सब चीजों के लिए दोबारा टाइम नहीं आएगा, प्लीज रिमेम्बर, मैंने कल भी बोला था कि कुछ टॉपिक्स ऐसे हैं जिसको आपको मेरे साथ ही करना होगा, बिकॉज सेपरेट टाइम यू विल गिव टू योर other topics which you are studying. For example, right now you are studying statistical mechanics also, so that will require more time. Okay, so iski practice aapko साथ साथ ही करनी है. Now please see this, the particular integrals. I told you that the value of particular integral will be given by 1 upon f of d into r, and this is operator that I told you now. So let us consider the different values quickly. If r is suppose some function, exponential function, then the particular integral will be equal to 1 upon f d e to the power ax, and this value is 1 upon. So you see this, we will when we will operate this, it will become 1 upon f of a. That means d will be replaced by a and e to the power ax. This will be the particular integral. So finally in particular integral, d has to go. So it will go in this way. Okay, d is equal to a. All right. So but in some cases what will happen, that f of a will become 0. Then what you will do? Then you will differentiate it. You will make it f dash a, and here you will multiply it by x and e to the power x, like that. Okay, and if again it becomes 0, then double derivative, and multiplication will be by x square. Okay, so if again it becomes 0, if f dash a is also going to be 0, then the particular integral will be 1 upon f double dash a x square e to the power ax, like that. So this is the first and very important case. Why exponential is important? Because you know that sine, cos and hyperbolics can also be written in the form of exponential function. Sine, cos and hyperbolic functions can be written in the form of exponential function. So exponential is very important. Please see this, and I hope it is clear. So I will just give quickly the formulae associated with all of them, then we will do questions. Okay, so this one is clear.
Yes, sir.
So let me go to uh, the B part, where r is equal to sine of ax. Okay, this rule will be same in the case of sine and cosine also. So particular integral will be given by 1 upon f of d sine of ax, and right here f of d square, because this operation will be only happening on d square, not on d. So it will become 1 upon f of minus a square into sine ax. Please see it carefully. So you can see that the d square will be replaced by minus a square in this case. The d square will be replaced by minus a square, and 100% similar is the case for cos also. So there, if you want to write particular integral like this, 1 upon d square cos ax, then it will be 1 upon f of minus a square and cos ax. So it will be like this. Correct? And the next case that I am going to take is So next case that I am going to take is ABCD, and that is, suppose you have a function like this 1 upon fd, and this side you have exponential function as well as some another function. Two functions are multiplied. Then what you will be doing, आप क्या करोगे, 1 upon, you will write f of, you will take exponential out like this, e to the power ax, and you will convert d to d plus a and then phi of x. Please see, this will be very important method. When you have two functions multiplied, that is exponential function as well as algebraic functions, two functions are multiplied, then this is the case. Clear to everybody? ध्यान से एक बार देखते रहना, कोई डाउट हो तो बताना. Then we have another case E, where suppose the function fd is there and this side you have some polynomial. So simply what you will do, you will take f of d inverse and x to the power n, open it using a series, binomial, etc., and then operate it on it. Okay, so open this series, fd inverse series, and operate it. So suppose, for example, using binomial, etc., you will open it and then operate it. So suppose here it will come 1 plus d square, so I will multiply it with each and every term. So if d is multiplied it by this, that means a single derivative. If d square is multiplied by this, that means double derivative. Okay, and finally sometimes this situation will arise, 1 upon d plus a phi of x. In such a situation, you will write e to the power minus ax integral phi x e to the power ax and dx. So this will be also very important.
Sir, this is function f of d plus a
Where?
in d.
This
In d, sir, d.
it is not clear.
Sir, in last one.
F, sir.
Sir, in
Last.
E, sir, last one. No, sir, last one.
F.
So this is 1 upon d plus a or function of d plus a?
1 upon d plus a phi x. Okay, I will tell you without example, you may not understand how this situation will arise. Huh? This is also some fd na, this is also function of d, but very particular, मतलब एक विशेष टाइप का फंक्शन है जो मैंने लिख दिया है, because it will appear at many places. So if you have noted it down, then we will go to problems, if this all is clear. The first problem that I am going to take is, now I have told you about the harmonic oscillators, but they were damped oscillators because the right hand side was 0. The right hand side was 0, so that they were all damped oscillators. But now what is going to happen, I can take right hand side in this present equation, so I am going to take a forced oscillator. That oscillator having right side will be known as forced oscillator. So let me take an oscillator, t2y by dx2 plus 6 dy by dx plus 8y is equal to cos 42.5 cos of 2t, 42.5 cos of 2t, and this is example of forced oscillator. Forced oscillator, you can see this is damping constant, then this is restoring constant, and this side you have a sinusoidal function which is actually the external force or something like that. So it is forced oscillator. So can we calculate quickly what is the value of fd this time? Function is d square plus 6d plus 8. Yes. So कॉम्प्लीमेंट्री फंक्शन के लिए क्या करना पड़ेगा? पहले CF कैलकुलेट कर लेते हैं. So I will write d square plus 6d plus 8 is equal to 0. So you will get d square plus 2d plus 4d plus 8 is equal to 0. So d common, d plus 2 plus 4 common, d plus 2 is equal to 0. So it will become d plus 2 and d plus 4 is equal to 0. So d is equal to minus 2 and minus 4. Correct? And they are real and different. So what is the complementary function? It is given by c1 e to the power minus 2x plus c2 e to the power minus 4x. Correct? Now about the particular integral. So up to this we have already done. This is the complementary function. And now about the particular integral. So it will be given by 1 upon d square plus 6d plus 8 into 42.5 cos 2t. This we have to calculate as a particular integral. I told you na this thing, that it will become f of d into y is equal to 42.5 cos omega t. So for particular integral, y will become 1 upon fd into this, which is this. And as a first step, what I am going to do is, I will write 42.5 into 1 upon d square will be replaced by minus a square plus 6d plus 8 into cos of 2t. Please see this carefully. D square is replaced by minus 2 square as written in the question itself.
Sir, -4 square या -2 square?
Sir, -2 square.
Minus 2 square. Okay. ये लिखा है ना मैंने, d square is replaced by minus 2 square. So it will become 42.5 into 1 upon, it will become minus 4. So it will become 6d plus 4, correct? And take 6 also common. So it will become 4 by 6 into cos of 2t. यहाँ पे बहुत ध्यान से देखना. 2 2 जा 4 and 2 3 6. Okay. Now या तो मैं लास्ट वाला लगा दूं जो मैंने आपको सिखाया था 1 अपॉन डी प्लस ए, इफ यू रिमेंबर. अब समझ आ रहा है वो उसकी सिचुएशन कैसे आती है. बट यहाँ पे मैं थोड़ा सा डिफरेंट भी जा सकता हूं. व्हाट आई कैन डू इज आई कैन अगेन क्रिएट 1 upon d plus 2 by 3 into d minus 2 by 3 into d minus 2 by 3 into cos of 2t, like this, which will give me, this will give me 42.5 by 6 into d minus 2 by 3 into cos of over d square minus 4 by 9 into cos of 2t, and which will give 42.5 by 6 into minus 2 square minus 4 by 9 and d into cos 2t minus 2 by 3 into cos of 2t. So when we will proceed with this value, it will give me 42.5 by 6, and what we will get here, minus 4, so minus 36 and minus 40 by 9, so minus 40 by 9, and what I am going to get here is d cos 2t will be minus 2 sin 2t and minus 2 by 3 and uh, cos of 2t. Okay, so this is my final particular integral. So you can multiply this quantity and tell me what you are getting.
Sir, it should be 42.5 cos 2x. Sir, in the equation we have three variable
Sorry,
y, x and t. It should be two variable equation.
अरे यार वो एक्स टी है, गलती से लिख गया, इतना तो समझो। ये यहाँ पे मैंने टी लिखा है ना, तो इसको भी टी लिख लो, एंड यहाँ पे भी टी लिख लो। Okay, so what is this value? Can anybody tell me
1.59, sir.
how much?
1.59.
So 1.59 into 2 sin 2t plus 2 by 3 cos 2t. This will be the particular integral. That is visible?
Yes, sir.
नोट कर लो अच्छे से। एक बार I will suggest you all to see the question carefully, complete question, and if there is any doubt you can ask, because this completes the full cycle of complementary function and particular integral. Can I erase this? और
Yes, sir.
सबने कर लिया भाई?
Yes, sir.
Okay, very good. So अभी कोई डाउट हो तो बताओ। आपने नोट किया कि वो जो डिनोमिनेटर में आ गया था 1/d + a,
Yes, sir.
उसको कैसे मैंने मेंटेन कर लिया था? इस बात को थोड़ा ध्यान दिया आपने कि कैसे मैंने उसको मेंटेन कर लिया था?
Sir, complex conjugate लेंगे.
हाँ, कॉम्प्लेक्स कॉन्जुगेट नहीं, कॉन्जुगेट लेके मेंटेन कर लिया था। ओके, सो let us now take another differential equation, and that I will write here d square plus 1 d square plus 1 y is equal to 5 times e to the power minus t into cos of t. Okay, suppose this is the equation, and then we have to solve it. We have to solve this equation. So that means y is a function of time, and we have to solve this equation. चलो एक बार जरा ट्राई करो क्विकली। स्टार्ट। First of all, go for this complementary function part, which will give d square plus 1 is equal to 0. That means d is equal to plus iota and minus iota. So I mean 0 plus minus iota. We write it in this form, na? So what will happen? The value of y will become a cos t plus b sin t, correct? The complementary function. The complementary function part will become, because what is alpha?
Zeros.
And what is beta? 1.
Plus
Alpha is 0 and beta is 1. So it will become like this. And what will be the particular integral part? That will be 1 upon d square plus 1 into 5 e to the power minus t cos of t. Correct? Now here two functions are multiplied. So what I am going to do is I am taking e to the power minus t outside, and it will become, so what is value of a here? Minus 1. So it becomes d plus a. So it will become d minus 1 whole square plus 1 into cos of t. देखो समझ आ रहा है? So it will become 5 e to the power minus t into 1 upon d square plus 1 minus 2d plus 1 cos of t. So which is what it will become? D square minus 2d plus 2 na? D square minus 2d plus 2. It will become like this. देखो भाई बताओ. Is that okay?
Yes.
Yeah.
And now apply the method that is given by 5 e to the power minus t 1 upon minus 1 square minus 2d plus 2 cos of t. So it will become minus 2d plus 1.
Yes, sir.
So minus 5 by 2 e to the power minus t, and it will become d plus 1. So it will become 1 upon d minus half cos of t. Is that okay? And now you remember what I am going to do. Minus 5 by 2 e to the power minus t d plus half over d square minus 1 by 4 cos of t, which will become minus 5 by 2 e to the power minus t d plus half and minus 1 again. So it will become minus 1 square minus 1 by 4 cos of t. Correct? And finally it will become minus 1 by 4 is what? Minus 5 by 4. So minus 5 and minus 5 will cancel and 4 will go in the numerator. So it will become 2 times minus sin t plus half of cos t. देखना जरा कैलकुलेट करके, क्या मैं सही बोल रहा हूँ?
Yes, sir.
Yes.
Yes, sir.
So
Yes,
what
sir.
is the value, final value of y? That is a cos t plus b sin t plus 2 times minus sin t plus half times cos of t. This is the final answer.
So there is e raised to power minus t term also.
Where?
So
Oh,
in the
yes,
particular
yes,
integral.
yes, wait. So from where? So here just multiply minus 5 by 2 e to the power minus t. Huh? Correct? So it will be
Only to the power minus t is multiplied.
minus 5 by 2.
Sir,
No,
no
5
5
by
is
2 I have
already
adjusted.
cancelled.
That I have adjusted only e to the power minus t. So 2e to the power minus t and this. So this is the
Yes, sir.
solution.
Yes, sir.
This is the solution. Thank you. I was missing that e to the power minus t. So note down that. So these right hand side things you should be able to handle, like I am doing, should be able to handle all that. Correct?
Yes, sir.
So if that is okay, I will erase this. Now another question is d square minus 4d plus 4y is equal to 8x square e to the power 2x sine of 2x. Okay? This is the question. So how many terms are there?
3 terms, sir.
3 terms are there. Okay? So I can solve it in many ways, but let me just follow the standard procedure. So complementary function will be given by d square minus 4d plus 4 is equal to 0, and it will be d square minus 2d minus 2d plus 4 is equal to 0. So d, I mean this is simply uh, d minus 2 whole square, na? Correct? This equation
Yes,
is
sir.
what? D minus 2 whole square. A square plus B square minus 2AB. So what is the value of D? 2 comma 2. Correct? So what will be the complementary function? C1 plus C2x e to the power 2x. Okay? When the roots are real but equal. Roots are real but equal. Fine? So what about the particular integral? That will be 1 upon d square minus 4d plus 4 into 8x square e to the power 2x sine of 2x. So first thing what I am going to do is take e to the power 2x outside. That I can do by putting d plus 2 whole square minus 4d plus 2 plus 4 into x square sine of 2x. Please see this. Correct? Take an exponential function outside and replace d by d plus a. If you see your list of operations that I have taught you. So what will be the particular integral now? That will be equal to 8 e to the power 2x into 1 upon d square plus 4 बोलो भाई plus 2d minus 4d minus
Minus
8
8 plus
plus
4.
4. So I
Sir,
hope
it
this,
should be d square plus 4 plus 4d.
sorry,
4D आएगा 2D की जगह
4d, sir. d square plus 4
Plus
plus
2D के
4d.
yeah,
not
yes,
4D
yes, 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 4d. Okay,
Cancel
so
4d.
this all will cancel. So what I am going to do is I will write 8 e to the power 2x into x upon 2d minus 4 x square into sine 2x. So I have to multi and then put a. So it will become.
Sir, how you have written this?
Second differentiate.
So it will become 8 e to the power 2x into 1 upon 2 times 2 minus 4 into x square sine 2x. But this time again it is becoming 0. Yes? And
Sir, only d square is remaining na, in the denominator.
x will be multiplied. So now what I will do?
Sir, only d
Differentiate.
square is
Sir,
remaining. Not
yes,
the
sir.
denominator.
Where?
In
Sir,
denominator, sir.
Acha, acha, sorry. I thought the whole denominator. D square is remaining, then no problem. So it will become sine of 2x here. Okay?
X square.
And
X square is this.
x square is there. And this will remain. So it will become 8 e to the power 2x into 1 by d square x square sine of 2x. Correct?
Yes, sir.
So now 1 upon d square is 1 upon d means integration. D is derivative, na? So 1 upon d means integration. So just you have to integrate it twice.
Sir, why aren't we replacing d square by minus a square?
Where? Why? What are you saying?
Sir, why aren't we replacing d
Why?
square by
Because x square is also there, na? Sine ax is not alone. Okay.
Okay, sir.
So if you want to go like that, either you integrate it twice. This is method number 1. Method number 2 can be like this. Sine of 2x को आप लिख लो e to the power I 2x. लिख सकते हो? Yes? Then what part you will have to take? Imaginary part of the answer.
Imaginary.
So now what I am going to do is, I can write 8 e to the power 2x into 1 upon d square is replaced by minus a square. So minus of 2I square. Are you understanding the point? And this side what I will get? E to the power I 2x and x square. And then please check, it will become 8 e to the power 2x into x square, and what here? That is important. I square will become minus 1 and this will become 4. So it will become 2. Correct?
Sir,
And
in iota, d replaced by d plus a. Why you written?
अरे यार मैं क्या कर रहा हूँ? Sorry. It will become, so that will become complicated, a plus b square and then na, so usko रहने देते हैं, because if it will become d plus 2 iota square, so it will become a square plus b square plus 2ab, so then we will have to do lot of stuff. So just integrate this twice, that you can do. So 1 upon d square means integration by twice, 2 times integration, and this write it as sine of 2x. So what will be one time integration? First function integration of second minus derivative of first function and integration of second. This is the one time integration, and do it one time more. एक बार और कर लेना, बस आंसर आ गया. Okay, now you can ask if you want to ask anything. I can do by that method, but immediately I observe that it will take another half page. So why to go into that? Just integrate it twice and you will get the answer. So once I have integrated, एक बार और integrate कर लो, you will get the answer. Okay?
सर ये माइनस साइन 2x by 4 कैसे लिखा?
अरे uv लिख दिया ना, इंटीग्रेशन uv क्या होता है? u v1 minus u dash v2 plus u double dash v3 dash dash dash. So u v1 इसका इंटीग्रेशन साइन का क्या होता है? माइनस कॉस 2x by 2, देन इसका डेरिवेटिव और इसका इंटीग्रेशन, और फिर एक बार लिखना पड़ेगा प्लस एक और टर्म आएगा, इसका डेरिवेटिव क्या होगा? 2 और इसका माइनस कॉस सॉरी प्लस कॉस 2x by 8. सो ये तीन टर्म्स होंगे और इसका एक बार और इंटीग्रेशन करोगे तब आंसर आएगा.
So we can always apply this UV formula by parts.
ऑलवेज मीन्स
In every function when we need
अरे
to do
भाई
by
ये
part
यूनिवर्सल फॉर्मूला है. हाउ आर यू सेइंग ऑलवेज? दिस इज यूनिवर्सल फॉर्मूला ना, दिस इज नॉट अ पर्टिकुलर फॉर्मूला. इंटीग्रेशन बाय पार्ट्स इज नॉट अ पर्टिकुलर थिंग ना, इसको कहीं भी अप्लाई कर सकते हो.
Okay.
बस u को ऐसा रखना कि वो खत्म हो जाए, तभी तो ये फंक्शन, नहीं तो इनफाइनाइट टाइम चलता जाएगा. सो u को एल्जेब्रिक ले लोगे तो इट विल फिनिश लाइक x स्क्वायर देन माइनस 2x देन 2 देन फिनिश. आई हैव टोल्ड यू ना uv, किसी और केस में भी मैंने बताया था आपको.
Yes sir, exponential case में ही होता है.
हाँ,
Yes, sir. Yes, sir.
सो रिमेंबर दैट. ये फुरियर सीरीज, फुरियर लैप्लास ट्रांसफॉर्मेशन, फुरियर ट्रांसफॉर्मेशन हर जगह यूज होगा uv फॉर्मूला. ओके, फिर लेट अस स्टॉप हियर.